All right, guys, going to be going over homework 3. In this homework, we're going to be talking about multiplying and dividing with integers, meaning whole, positive, and negative numbers, and decimals. Okay. First things first, quick review of multiplying, just in general. Let's say I said 5,407. Multiplying without signs, we're just going to do quick multiplication here. And let's say we did times 23. You might see the times symbol in between them, you might not. Two parentheses next to each other always indicates multiplication. So just a quick review on how to multiply longhand, right? Maybe a while since you've done this. 3 times 7, 21, carry the 2. This is something you're supposed to remember already. Just again, FYI, I'm just going over it real quickly before we get into the new stuff. Let's quickly review how to multiply. 3 times 7, 21, carry the 2. 3 times 0 is 0, plus 2 is 2. 3 times 4 is 12, carry the 1. 3 times 5 is 15, plus 1, that's 16, right? Go ahead and take the number, multiply through, move to the next number. When you move over, don't forget that you need a placeholder 0. If we moved over another time, we'd need another placeholder 0. Be careful about that. 2 times 7 is 4, carry the 1. 2 times 0 is 0, plus 1 is 1. 2 times 4 is 8, and 2 times 5 is 10. All right. Once you've multiplied out the 3 to everything and the 2 to everything, you just add it all back up. 1 and 0 is 1, 2 and 4 is 6, 2 and 1 is 3, 6 and 8 is 14, carry the 1, 1 and 1 is 2, and 1 is 1. All right, so this is just a quick way to the quick overview of multiplication there. Again, something you are supposed to remember how to do. What we are going to talk about today that's different is the decimals, and that's what we're going to spend most of the lecture on. Real quick, though, I would remind you about the signs. Usually this is not something people have a ton of trouble with because unlike addition and subtraction, multiplication and division is a little bit easier with the signs, right? Because they're fixed. If the signs are the same, like they were here, the answer comes out positive, period. If the signs are different, negative and a positive, positive and a negative, the sign comes out negative. And that's nice because that's fixed for all multiplying and dividing. So unlike addition and subtraction where you got to go through and determine which one's bigger, which one has more left over, when you multiply and divide, the signs are fixed. So we said positive, 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 and we didn't have to spend any more time on that, okay? So I'll write that down again on the next page, but just keep in mind the signs for this multiplying and dividing are fixed. And so we're not going to spend a lot of time on the signs. We'll kind of work them as we go. But again, they are fixed, so they don't change from one problem to another in the sense of the rules. So once again, if they're both the same sign, it will end up being positive. If they are different signs, it will end up being negative, just to keep that up there. All right, so now, how do you multiply decimals? Well, the good news is it's not tremendously different from multiplying with regular numbers. Let's say I said negative 3.72 times 1.4, all right? First thing you can do is you can tell me that the sign of the answer is negative already, right? Because when you multiply and divide, it is fixed. A negative number times a positive number, negative, already taking care of the sign. How do you multiply with decimals? Well, you really don't until they end. The decimal doesn't come into play until the very end. When I set this up, first of all, notice I didn't even line the decimal up at all. When you multiply and divide, lining the decimal up is not required. It's only required when you add and subtract. So in that sense, multiplying has even less rules than the addition and subtraction. You don't even need to line the decimal up. And watch what I do on the next step. I'm not going to use the decimal at all when I multiply. 4 times 2 is 8. 4 times 7 is 28. Carry the 2. 4 times 3 is 12. Plus 2 is 14, right? Just like normal. Same thing. I'm going to move over to the 1. Put my placeholder 0 down. 1 times 2 is 2. 1 times 7 is 7. And 1 times 3 is 3, and then we just add it all up. 8 and 0 is 8. 8 and 2 is 10, carry the 1. 4 and 7 is 11, plus 1 is 12, carry the 1. 1 and 1 and 3 is 5. So we got the number 5208. Those were our digits. It's not the answer, obviously. You're taking 3 and change times 1 and change. The answer is not 5,208, right? But those are the correct digits. So when you multiply decimals, the first thing you do is just multiply like normal. Get your number. Then go to the end of the number and move left the same number of places of decimals you had in the problem in total. So in this case, we had 1, 2, 3 decimal or point places behind the decimal in total. Make sure you see what I'm saying. We had 2 places behind the decimal here. We had 1 place behind the decimal here. So collectively 3. So we go to the end of our problem, moving from right to left, and we move over 1, 2, 3 places, and 5.208, or negative rather, negative 5.208 is our final answer. All right, and that is how you multiply decimals. We'll obviously do another couple examples here, but that is how it's done. Notice again that I did not use the decimal when I multiplied. So if you knew what 372 times 14 was, you can just slap the number down and count the decimal to the left. You only have to do the multiplication if you need to. You will most of the time, but I mean, it is an option. Let me go ahead and squeeze this in here if I can. Don't box this off so I don't confuse anybody. Real quick, you can do these in your head if you know the numbers and can do the multiplication in your head. So let's say you had 1.2, and I'm not advocating you do this in your head. I'm simply bringing up the point that it can be done. Let's say I asked you to multiply these 3 decimals together. Well, you could do it out the long way, and if you want to try it, sit down, pause the video, and try it right now. It's not a big deal. But you take these 2 numbers here, multiply them together, whatever you got out of that, then you multiply it by this number over here, and you just get your answer in totality, right? But again, the decimals themselves don't have anything to do with the number answer. So if you thought about this number without the decimal, wouldn't it just be 12? And if you thought about this number without the decimal, wouldn't it just be -3? This number doesn't have a decimal, it's just -2 anyway. And if you multiply these together, 3 times 2 is 6, times 12, that's 72. That would be your number. And this is what I meant about doing the number part in your head. If you can multiply the numbers you're given, if you took the decimal out and you were still able to go back through and multiply the numbers together in your head, then your number answer is still correct. So 72 is what we would get as a number. Now we have to go back and say, well, there's 1, 2, 3 places behind the decimal in total in this problem. 1, 2, 3, none over here. So collectively 3 places behind the decimal in the problem. Just like last time, we're going to come down to the end, starting at the right and go left, 1, 2, 3 places. Now in this case, there was a gap, which we fill in with a 0. So our answer to this problem was 0.072. If you don't like to do it in your head, wait, first of all, I wouldn't ever do that on a test. I just wanted to point it out that it's possible. But if you don't like it, do it out longhand. It only takes a few more minutes. It's not a big deal. Ask yourself why it was positive, though. Just do that, right? Because we had a positive times a negative, which is negative, times another negative, which is positive, okay? So 2 quick examples on multiplying decimals. Let's do one more. Because luckily it is the same thing every time. The rules don't really change. From one problem to the next, it's very, very similar, all right? So let's go ahead and try one more. If you'd like to try this one out on your own and then come back and look at what I've done, it's not a bad idea. Let's say we had 0.094 times 87.3. Again, try this one out on your own. See if you're following the lecture, see if this is making sense to you, and you know, go from there. I'm gonna go ahead and do the signs and say positive, right? Negative, or positive times positive is positive. Negative times negative is positive as well. If the signs are the same, it will be positive. And let's go ahead and multiply. Which one you put on the top doesn't matter. Which one you put on the bottom doesn't matter, because you don't even have to line the decimal up. All you have to do is multiply these numbers and worry about the decimal at the end. The idea is, again, multiply the numbers together, and then from the end, count from right to left the number of decimal places you had in the problem. So here we go. 4 times 3, that's 12, carry the 1. 4 times 7, that's 28, plus 1, that's 29, carry the 2. 4 times 8 is 32, plus 2, that's 34. We move on to the next number. Because I'm moving over, there'll be a 0 placeholder here. 9 times 3 is 27, carry the 2. 9 times 7 is 63, plus 2, that's 65, carry the 6. 9 times 8 is 72, plus 6 is 78. And in fact, I went ahead and drew my line, but if we wanted to, right, to be, you know, technically proper here, we'd have one more number. We'd put in 2 placeholder zeros. 0 times 3 is 0. 0 times 7 is 0. 0 times 8 is 0. You probably knew that, and you probably skipped it, but just to make the point that it is there, and it is something we could, you know, we do have to watch. 2, 9 and 7 is 16, carry the 1. 4 and 5 is 9, plus 1 is 10, carry the 1. 1 and 3 is 4, plus 8, that's 12, carry the 1. and 1 and 7 is 8. So when I multiply all these digits out, I get 82062. We know it's a positive because both numbers were positive already. The question is, where does the decimal go? We'll go back to the beginning of the problem and again, count the total number of places behind the decimal. We had 1, 2, 3, 4. So in this problem, there were 4 places behind the decimal. So in our answer, there should be from right to left, 1, 2, 3, 4 places. So our number will be 8.2062. Take a minute, make sure that makes sense to you. That's multiplying decimals, giving us 3 examples there to look at. Nothing really crazy. They don't change much from problem to problem. So once you've got the hang of that, you should be fine. All right? So take a minute, make sure that makes sense to you, and then we'll move on to the division. All right. Dividing with decimals is really where people have trouble, and it's honestly, it's not the division with the decimals, guys. Most people have trouble with the dividing in general. So let's go ahead and start there. Let's start with a non-decimal problem, just to make sure you remember how to divide. Let's say I said 1,515 divided by 3. Okay, no decimals, nothing to worry about. We do have to worry about our sign, but in this case, they're both positive. So again, the answer will be positive. First things first, when you're setting up long division, let me see if I can get that light a little better. We're setting up long division. The number you divide by goes outside the box, not the smaller number, the number you divide by. So this is 1,515 divided by 3. So 3 goes outside the box. 1,515 on the inside. Be careful. If you're telling me the answer is 55, you're jumping through it and you're not doing all the steps. Be careful. There are 4 steps to long division. Divide, multiply, subtract, and bring down. Okay? Sorry, the light keeps changing on the camera. I'm not sure why it's doing that. Divide, multiply, subtract, and bring down. Those are the 4 steps, and you repeat them over and over. So again, let's do it without decimals first. 3 goes into 1 0 times. Now you're tempted to move over to the 15 right away. That's fine. That 0 is not required here, but if we had decimals, it might be. So my suggestion in the future is if you move over, make sure that you bring a 0 in the spot that you skipped, okay? Just to be safe. It's never wrong. You'll know if the 0 doesn't need to be there and you can drop it later, but it's certainly a good safeguard. So 3 goes into 1 0 times, moving over. 3 goes into 15, divide 5 times. Now we're going to multiply. 5 times 3 is 15. Now we will subtract. 15 minus 15 is 0. Now we're going to bring down. Now we're going to start the process again. 3 goes into 1 0 times. We'll go ahead and do it the whole way out this time. 0 times 3 is 0. That's the multiply. Now we'll subtract. 1 minus 0 is 1. And now we'll bring down. As long as you have stuff to bring down, you got to keep going, right? 3 goes into 15 5 times. 5 times 3 is 15. Subtract. There's nothing to bring down. The number ended cleanly. So we have positive 505 as our answer here. Be a little bit careful when you're dividing, guys. It's easy to just say, oh, 3 goes into 15 5 times, and 3 goes into 15 5 times. If you don't do out the whole division algorithm, as it's called, you can skip numbers, you can miss numbers. You really need to practice with this. So we're going to do several examples here. The other issue is dividing with decimals has 3 possible outcomes. We'll examine each. So that was division, but with regular integers. Excuse me, let me get this squared away. That was division with integers, which just should end like this. If you're dividing with decimals, there's 3 outcomes you need to be aware of. It might just end or terminate, right? You do the multiple or the division and it just stops. Great. It might repeat, or you may need to round. So we're going to look at examples of all 3 of those, but just keep in mind, all 3 of these are possible outcomes when you divide with decimals. When you're dividing regular whole numbers, it shouldn't happen like that. It should be very straightforward. But if you get into decimals or if you get into numbers that aren't clean, then it could end, it could repeat, or you might end up rounding. It just simply depends on the situation, okay? So let's go ahead and jump right into dividing with decimals. Again, if you need help with the basic long division, let me know. But I think for the most part, it's the decimals that people struggle with in this chapter. So let's say we said 2.78 divided by -4. Okay? First things first, hopefully you're already jumping on it. Positive divided by a negative. We know the sign of the answer to be negative. We don't have to worry about the sign again. Now we can go ahead and set up our division. This is 2.78 divided by -4. The one you divide by is the one that goes on the outside. 4 goes on the outside, 2.78 goes on the inside, and we start our division. Except this time there's a decimal. So what do? Well, really the issue is the decimal doesn't do anything. It just comes up and you go. Now remember what I said a minute ago though. With decimals, there's 3 options. It might end cleanly, it might repeat, or we may have to round. There's no instructions to round here, so presumably this is going to end or repeat. So go through the 4 steps of the division algorithm one at a time. 4 goes into 2, 0 times. 0 times 4 is 0. We're going to subtract and bring down. 4 goes into 27, 6 times. 6 times 4 is 24. We're going to subtract and bring down. 4 goes into 38 9 times. 9 times 4 is 36. We're going to subtract, and now we've run into something that happens in decimals a lot. It didn't end cleanly because we still have this remainder here. Now, we're not using remainders. Decimals and remainders are not compatible. So what you have to do, because this didn't say round, and it didn't tell you to stop here, when you have a decimal problem that doesn't end cleanly, you have to keep adding zeros until it does. So notice I brought the 2, we did the 2, we brought down the 7, we brought down the 8. I ended up with the 2. So what we have to do is keep dividing by adding zeros until this ends. So 4 goes into 20 5 times. 5 times 4 is 20. And now we have a nice clean end. All right? So negative 0.695. That 0 in front is not required. If you want it there to make yourself feel better, to keep it straight, you can. Okay? All right. Not sure if the audio video may have just gone out. This thing has been giving me trouble. So hopefully that's still recording. I think it is. So we'll keep going. So there we go. That's how to divide with decimals. And that's one for an example that ended. What if we had, let's see if I can get it in here. Not waste so much paper. Let's say I said something like this. What if I said 2/9 and I told you to divide it? Now you'd be right to look at that and say that's a fraction. Well, which is why I'm giving you the instruction to divide. Fractions are division, right? Isn't that 2 divided by 9? 2 divided by 9. So 9 would go on the outside. 2 would go on the inside. Now here's the trick though. You got to know where your decimal is, just like last time. First thing we did was bring the decimal up. Where is the decimal when you're dividing 2 and 9? They're both whole numbers. Well, remember our examples from previous lectures. 3 is the same thing as 3.0. So 2 is the same as 2.0. So the decimal goes behind it because it's a whole number. Go ahead and bring up the decimal and let's start to divide. 9 goes into 2, 0 times. So I did it out last time. Remember, if you want to skip over to the 20, you can. Just make sure you put a 0 for the 2. 9 goes into 20, what? Twice. 2 times 9 is 18. Subtract and we get a 2. Remember what we said last time. If it doesn't end, you have to keep bringing down zeros until it does. So I'll bring down a 0. 9 goes into 20, 2 times. 2 times 9 is 18. Once again, it did not end cleanly. So we're going to have to bring down another 0. And you can probably already see where this is going. This is just going to keep happening over and over and over again. 9 goes into 20, 2 times. 2 times 9 is 18, etc. So this is an example where the decimals will continue to just proliferate. 0.22222, they will never end. So the way we write this, once you realize you have something that's repeating, is we say 0.02 with a line over the 2 to indicate that the 2 is repeating, not the 0 and not the decimal. All right? Take a minute, make sure it makes sense to you, and then we'll move on and do another example. All right, so let's go ahead and move on to the next problem. One thing I'll say while I'm transitioning here, some of y'all mentioned that the lectures aren't super long. Remember, in a normal class, I would be pausing, we'd be taking questions, I'd be doing review problems, things like that. So this is sort of a condensed lecture with no pauses, no breaks. And that's why I said you really need to pause the video. You really need to take time. If you're having trouble, slow it down, you know, go step by step. There's no issue with doing any of that. All right. So let's go ahead and divide another decimal, do a couple more examples. This time, let's do one that needs some rounding, because we said that is a possibility as well, right? We might need to round. What if I said 13 divided by 85? So there might come into the situation where there is no decimals at all. Again, I don't know what's going on with the lighting on this thing. Sorry, guys. you might come in a situation where you divide 13 divided by 85, and there are no decimals in the problem itself, sort of like the last one, the 2 and the 9, but decimals will appear in the answer because 85 doesn't go into 13 cleanly even once. So 13 divided by 85, that puts 85 on the outside and 13 on the inside. Before you start going crazy here, remember where your decimal goes. Your decimal goes after the whole number, so 13 points, and then we bring the decimal up, okay? And now we divide. Let's go ahead and say we're going to round to the nearest hundredth. Now, if you need to review your decimal place values, I'll do a quick one here. But, you know, this is something technically we are supposed to already remember. So let me sort of write out a large number here. After the decimal place, there is no ones place. After the decimal place, the first one is called the tenths. The one after that is the hundredths, TH. All of these have TH on the end. The one after that is the thousandths, okay? The one after that is not the millionths, that's the 10 thousandths. Then we would have the 100 thousandths. And then you'd have millions and 10 millions and so on. So, you know, it's not something that's going to happen a lot. We're not going to go crazy into the long decimals where you're going to have to be rounding out into the millions. But just the point that it can happen, and you know, you should be aware of your decimal place values. Here, we're going to round to the nearest hundredth, which means the second place, okay? So what that means is when I get up here, I don't need to divide until the end of time. I only really need to divide until I get to the required place. All right, so keep that in mind. Unfortunately, I sort of ate my space up here, so let's go ahead and do it on another sheet of paper. 13 divided by 85. So once again, 85 goes on the outside, 13 goes on the inside. Decimal after the 13, bring it up, and let's go ahead and start to divide. 85 doesn't go into 1 or 13, so we can go ahead and put our zeros here and move over. 85 goes into 130 how many times? Now, I picked this problem for a reason, because a lot of people will say to me, well, I don't know my 85 times tables. My friends, I do not either. I don't memorize my times tables up. I don't know my 13 times tables, let alone my 85s. So at a certain point, you will be guessing. It's okay. Let's say we thought it was 2. I think it might be 85 times 2. Off to the side, try it. See if it's too big, too small. 2 times 5 is 10, carry the 1. 2 times 8 is 16, plus 1, that's 170. It's too large. So this will only go in 1 time. So if you have to guess and try some things on the side, it's not a problem. 1 times 85 is 85. Now we're going to subtract, borrow, be careful. 10 minus 5 is 5. 12 minus 8 is 4. Again, slow that down if you need to. So we got 45. Notice now we're at the tenths place, though, and we were supposed to be rounding to the hundredth. So we need to go out at least one more, right? We need to go out at least one more place. So we're going to have to drop a 0. 85 into 450. I have no idea how many times that goes. 8 times 5 is 40, so let's come down here and try 5. So sometimes you will have to guess, guys, and that's sort of the point with this problem. They're not all going to be super quick and simple. 5 times 5 is 25, carry the 2. 5 times 2 is 8, 5 times 8 is 40, excuse me. 5 times 8 is 40, plus 2 is 42. 425, so 5 was the correct number. If it would have been too big, I would have backed it off. 5 times 85 is 425. Subtract, and we get 25 left over. Now, can I stop? Because we're supposed to round to the nearest hundredth, and we're at the hundredth. Well, remember how rounding works, guys, from back when you were taught rounding however many years ago. To round, you need to know the place after where you're trying to round to, right? This is the hundredth, but I need to know what the next place is, so we actually have to go one more place value. So now we're going to be doing 85 into 250, but I think we already know our answer. We already did 85 times 2 is 170. I don't think I can add 85 into there and keep under 250, but if you want to, try it. If you think it might be 3 times, take it out and try it. 3 times 5 is 15, carry the 1. 3 times 8 is 24, plus 1 is 25. 255. 3 is too big, so we're going to go with 2. 2 times 85 is 160. Subtract, do your borrowing, again, be careful about that and bring down. And we got 90, but see, now I don't care anymore. Now I have enough decimals. So we had 0.152, and the answer told us to round to the nearest 100, which is this value. So what you're going to do is cut it off there. Your answer will not go past the 100th, but you're going to use the next number to tell you whether to round up or down, right? So if the number was between 0 and 4, we're going to round down. If the number is between 5 to 9, we're going to round up. So we had 0.152. We're cutting it off here. The next number, the 2, is low, 0 to 4. It's less than halfway. So we're going to round down. We're going to drop it off, and we're going to get a final answer of 0.15, rounded to the nearest 100th. It's a little sloppy, guys. I don't have a lot of room here, unfortunately. It's a lot nicer on a board when you can kind of go back and forth, but we have to cram it all into one little piece of paper when we're doing these dot cams. So it is what it is, I suppose. So again, 85 into 13 gave us 0.152, and this actually would continue on, and I don't think it stops. So be a little bit careful. If the instructions tell you to round to the nearest number, 100th, 10th, whatever, make sure you're paying attention to that, or you might end up dividing way too far out. We got a number of 0.152. The 100th is the second place after the decimal, so we cut it off there. And we use the number after that to determine that we should round it down to 0.15. All right? Let's do one more decimal division problem. I know it's tedious. These first few homeworks, guys, are tedious. It's just a lot of computation, a lot of arithmetic, not a lot of theory, not really anything interesting to talk about, unfortunately, okay? So we just got to get through it. Let's try one more. You try this one on your own. Let's take -7, and let's divide it by -0.08. This one was a little different than the others, so this is the last kind of twist, I guess, we got to throw in the mix. Because why? Think about it. What's different about this one than the others? Well, this time, you're dividing by a decimal. And if you go back and look at the last few problems, we haven't done that. In the problems, we divided by 4, we divided by 3, we divided by 9, and we divided by 85. We have not divided by a decimal itself. So there is a special rule there. But before we get ahead of ourselves, negative divided by negative, positive. Take care of the sign. You don't need to worry about it again. So -7 divided by -0.08. So 0.08 goes outside the box, and 7 goes on the inside. All right, actually going to try to maybe make that a little bit bigger. 0.08 on the outside and 7 on the inside. All right. Now, again, just like last time, you need to know where your decimal is before you start dividing. So just like last time, this is the whole number 7, the decimal is there. Now, here's the issue. You can't divide with a decimal outside the box. And it just simply doesn't work. Decimal division does not work with a decimal inside the box and a decimal outside the box at the same time. So what we're going to do is take this decimal that's on the outside of the box and move it over until we have a whole number. Because that's how we divide, by whole numbers. Don't move it over once, because that would give you 0.8, which we don't want. Move it over twice to give you 8. But you guys already know this, I'm sure. What you do to one number, or what you do to one side, you got to do to the other side. So because we took this decimal and moved it over twice to the right, we're going to have to take this decimal and move it over twice to the right to make this 700. So again, why did I do that? Because you cannot divide by a decimal. If you have a decimal on the outside, you have to move it over until it becomes a clean number. Then you take the inside number and move the decimal to the right the same number of times. So what we're really doing here is 8 into 700. Don't forget your decimal is now on the end. Bring it up, and let's go ahead and just start dividing. 8 goes into 7 0 times, so we can skip over to 70. 8 goes into 70 how many times? This is when knowing your times tables will really speed things up, guys. 8 goes into 70 8 times. 8 times 8 is 64. We're going to subtract, and we're going to bring down. And now we start all over again. 8 goes into 60. How many times? Well, 7. 7 times 8 is 56. We subtract, and it didn't end. Do you remember what to do now? Remember with decimals, right? If it doesn't end, we got to add another 0. We got to bring it down. 8 goes into 40 5 times. 5 times 8 is 40. And this time, we got a nice clean ending. So in this case, the answer was positive 87.5. So we've done several examples with decimal division, guys. We've done it where we divided two whole numbers that ended up with a decimal. We ended up dividing a whole number into a decimal, and we've divided now a whole number by a decimal. Remember, there are several outcomes that can come out of decimal division. You can get a number that will stop. You can get a number that will repeat. You may have to round the number yourself. It just depends on the instructions. If it doesn't tell you to round, though, do not anticipate rounding. Rounding is one of those things you really only should do if you're told to do it. All right, so take a minute, review this, review the last few problems. We've got a few more things to talk about, but this is the ugly stuff, hopefully, is out of the way. All right, now that we got that out of the way, let's go ahead and wrap this up. There was a couple of emails last time about order of operations. And when you're adding and subtracting, which is what we covered last time, order of operations isn't really, there really isn't any. You can add and subtract in whatever order you like. I kind of went over it with you guys. I like to group them, put my negatives together and put my positives together, but the order you do those in is fairly irrelevant. When you add in a multiplication and division, though, now we have to talk order of operations. So quickly, the order of operations is as follows. I know a lot of people like to say PEMDAS. PEMDAS is wrong, unfortunately. And I'll kind of explain why here in just a second. We're not going to have a full-on lecture about order of operations. Order of operations is one of those things we expect you to remember from the past, but I will review it from time to time, of course. And it will be in the homework here and there, so we'll take a minute and talk about it here. This is the order of operations. The first step is grouping symbols. So parentheses, brackets, things like that. Exponents and roots are the second step. This really shouldn't be happening on any of the homework, so you don't need to worry too much about that yet. The third step is multiplication and division, and this is where PEMDAS gets it wrong. PEMDAS, please excuse my dear Aunt Sally. The M comes before the D, and unless your math teacher in the past clarified that point for you, you could think that multiplication comes prior to division. It does not. Multiplication and division are on the same step, so multiplication and division occur at the same time, meaning whichever one you get to, going left to right. So, quick small example. Let's say I said 8 divided by 4 times 2. 8 divided by 4 times 2. Take a minute, tell me what you think that is. You should be either telling me it's 4 or it's 1. Those are the only two answers you should be getting. Because if you divide first, 8 divided by 4 is 2, and 2 times 2 is 4. If you multiply first, 4 times 2 is 8, and 8 divided by 8 is 1. So those are the only two real options. The issue is, are you multiplying first or are you dividing first? Order of operations says multiplication and division are the same step. So neither one comes first, right? It's like having two kids. You can't choose one over the other. One's not your favorite. They're both equal to you. It's whichever one you come to first, going left to right. So in this case, first, we got the division first. 8 divided by 4 is 2, and 2 times 2 is 4. If you said 4 times 2 is 8, and 8 divided by 8 is 1, you did the multiplication before the division, which means you went right to left, which is out of order. That does not mean, don't misunderstand me, that does not mean that division always comes first. If the problem was reversed, and we had 8 times 4 divided by 2, just box these off so I don't confuse anybody. This time, the multiplication would come first because going left to right, I got to the multiplication first. There's no brackets or parentheses or anything like that. So in this case, 8 times 4 would be 32, divided by 2 would be 16. So sometimes you divide first, sometimes you multiply first. It depends on which one comes first in the problem. Multiplication and division come at the same time. They do come before addition and subtraction, so I would point that out. So let's go ahead and get a little order of operation problem under our belt here. Some of y'all were having issues with them in the last homework, so I said I'd go ahead and do one this time. So we got 27. This is straight out of the homework, by the way. 27 minus 9 divided by 3. And then we got minus 39 divided by 3 times 4. You can always email me questions, guys. This last time I got quite a few order of operations questions, so I figured we'd go ahead and just do an example here. Order of operations, first step is grouping symbols, left to right. So I see this parenthesis here and that parenthesis there. Left to right, so we're going to do this one first. So we go inside of the parenthesis and we have minus and we have divide. Division comes before subtraction. So 9 divided by 3 is 3. And what we have now is 27 minus 3 in parentheses. Okay? There's the light again. I don't know why it keeps doing that. This is unfortunately the same doc cam that was giving me trouble when I tried to record the video the first time, so it may just still be struggling. I'm not sure what's happening. 27 minus 3, let's go ahead and finish this out, gives us 24, okay? So that first parenthesis, the whole thing worked out to just 24. Then we come over to this side, don't forget your minus in the middle. 39 divided by 3 times 4. So again, are we gonna multiply or divide first? Well, because division came first, left to right in the parentheses, we're going to divide first. If the multiplication had come first, we do the multiplication first. 39 divided by 3 is 13. Times 4 is 52. Take a minute, make sure that makes sense to you. And then we just have to work this out. We got 24 minus 52, a positive number and a negative number, so we're going to subtract them. Larger number goes on top when you subtract, always. Borrow. 12 minus 4 is 8. 4 minus 2 is 2. So 28. And we keep the sign of the larger number. So negative 28. So just take your time with the order of operations, guys. They can get really overwhelming if you just jump right into them. Slow it down. Start with the brackets and parentheses. Work those out. Once you're inside those, you follow the same order of operations. So hopefully you won't find these too big a deal. There's not too many in the homework, but there's a handful. One last thing we want to talk about, and is actually something we talked about with addition and subtraction, so hopefully this will be pretty familiar to you. Remember those properties? We talked about commutative and associative property, right? Commutative and associative. And we had said last time that they held for addition only, right? Not for minus. Because remember what commutative said. Commutative said you could put the numbers in any order you want, but you can't do that if you're subtracting. Associative said you can do them in any order you want. Well, that does not work if you're subtracting. But it does work if you multiply. So those two properties we talked about last time, commutative, associative, also apply for multiplication as well. So for example, you might see something that says 2 times 3 times 4 equals 4 times 2 times 3. Notice the order of the numbers change. 2, 3, 4, 4, 2, 3. Go ahead and multiply that out if you need to verify. 2 times 3 is 6, times 4 is 24. 4 times 2 is 8, times 3 is 24. So the order that you write your numbers in, if it's all multiplication or addition, doesn't matter. Associative says, look, what if we grouped them together? What if I said 5 times 3 times 2 equals 3 times 2 times 5? Oops, actually, I'm jumping the gun. Hold on, I just did commutative as well. Let me keep this to just associative, sorry about that. 5 times 3 times 2, I'm getting ahead of myself for the next question. 5 times 3 times 2, and maybe versus 5 times 3 times 2. Notice what I was doing in the last problem that was incorrect is I changed the order of the numbers. That's commutative. You can do both, as we saw in the last homework, where you had some that were both, some that were neither. But just for the example, I wanted to keep it just one at a time. So commutative means, again, the number order changes, 2, 3, 4, 4, 2, 3. Associative says the parenthesis order or the order of operations changes. So what would you do first on the left side? Well, you do 5 times 3, right, which would give you 15. Then 15 times 2 would give you 30. On the right side, we're doing 3 times 2 first, a different order of operations because the parentheses are different. 3 times 2 is 6, and 5 times 6 is 30. So once again, the same two properties hold for multiplication. The order that you write the numbers down in does not matter as long as it's all multiplication. And the order that you do them in does not matter as long as it's all multiplication. 5 and 3 went first here, we got 30. 3 and 2 went first here, and we got 30 as well. So hopefully that's making sense based upon the last lecture. Let's look at an example. What might you be asked on the test or the homework? Well, I might give you something like this. I might say 4 times 5 times 6 equals 6 times 5 times 4. So just like last time, the same 4 options. 1, is this showing you only commutative? 2, is this showing you only associative? 3, is this showing you both of the properties at once? Or 4, is just showing you neither one and it's just a bunch of random junk. Same questions I asked you on the multiple or the addition and subtraction homework. Well, think about it. Did they commute? Commutativity means the order of the numbers changed. We had 4, 5, 6, 6, 5, 4. So definitely commutative. Maybe not only, but definitely at least commutative. Did it associate? Did the numbers that are associated together change? 5 and 6 are associated together here. Those are the ones we do first here. What would we do first on the right side? Well, the same numbers, yeah? It's still 5 and 6. We didn't change the association. All we changed was the order the numbers were written in. So the association did not change. 6 and 5 are associated together here, and 6 and 5 are associated together, or in parentheses here. So the association did not change. This is only commutative. If the association changed, then it would be 6 and 4 in the parentheses, or, you know, or some other combination. So be careful with these. They're a little tricky. If you have any questions, you can, of course, email me as usual. Use the homework help aids. Use the tutoring guys. Make tutoring sessions with the Zoom tutor, or with the tutors via Zoom in the library. Work with each other. Send me emails, whatever you need. Make sure you give yourself enough time to do it. And don't forget to reach out if you're having trouble. And I will see you guys on the next one.